Hi, everyone. My name is Ramona Irie, and I'm with NAVFAC XWIC in Port Hueneme, California. I'd like to thank you all for attending today's OER2 webinar on PFAS RI Sampling and Analysis Plan case studies. Our speakers today are David Steckler, Dennis Parker, and Dan Huckett. David Steckler is an RPM at NAVFAC Washington, and he has 25 years experience as a hydrogeologist in the Navy's ER program. Dennis Parker is a contracted RPM in the BRAC PMO West office. Dennis has 35 years of experience performing environmental investigations, with 29 of those being on Navy projects. Dan Huckett is a professional geologist and project manager for Jacobs with 24 years of experience performing environmental investigations. We will hear from all three of them on today's webinar about the sites that they have managed where they use innovative strategies and proactive project management to get SAPs approved and implemented for RIs at PFAS sites. As usual, at the end of the presentation, we will be having a Q&A session, but we encourage you to submit questions anytime during the presentation in the Q&A box. This presentation is being recorded, and the recording will be posted onto our ERB website and also onto our YouTube page. Following the webinar, we'll send out a short survey, and we ask that you all complete the survey, which will take just 2 minutes or less, as this is our main form of feedback for these webinars. Just a reminder that your participation on this webinar is voluntary, and just wanted to emphasize that this webinar is intended to be informational, and we are not endorsing any specific product or technology. We try very hard to ensure that all of the information is accurate, but there's no guarantee that the approach we present will work at your site. So before our speakers begin their presentation, I'd like to invite Melanie Quito from NAVFAC headquarters to say a few words about the OER2 webinars. Melanie?
Thanks, Ramona. Hello, my name is Melanie Quito. I'm with NAVFAC headquarters in Washington, D.C. First of all, I want to welcome everyone onto this exciting webinar. We've been doing this for about 10 years now, and I'm so proud that we have this available, that we share anything that we have to really talk about quarterly, about if it's on policies or guidances or techniques. And obviously, like for today, the hot topic obviously is PFAS, but there's a lot of projects that are now going into the RI stage, RISI stage. And so the SAPs, the sampling analysis plans are being created by folks. So a lot of folks aren't really know what to do. So this is an exciting topic here. So why talk a little bit about the OER2, which is the Open Environmental Restoration Resource. This is for anyone who really wants to learn about these type of things when it comes to RPMs, RTMs, contractors and such. And remember, this is a two-way process. We not only share things, but we also want to get feedback from everyone too. And this is really only possible by folks who are listening, by folks such as the three gentlemen who are talking today, who volunteered their time, who want to share their lessons learned for everything, so everyone can benefit from that. So we also welcome you to, if you have anything you want to share, please let us know, and you can either contact me or there's an email on the bottom here, the XWIC of .t2 that you can ask for that, or Amy. So with that, with this particular presentation today, I think it's really meaningful, and also hopefully you'll get something out of it. With these three gentlemen who are really the pioneers at this of actually doing some SAPs, you would think that a lot of the SAPs you do for PFAS is kind of the same, which it is. A lot of it you're going to see the same. But I think the main thing with this, hopefully you'll see that it's really not a one size fits all for everyone. So you're going to actually see such as the first one, which David will talk about at PAX, how he actually was able to optimize his SAP by actually grouping some sites strategically and seeing what's best that works for him. And for Dennis, he's going to talk about his TI, where some of the challenges he had because it was near the water, but also because he had so much information, he was able to skip the SI and go straight to the RI, again, really optimizing his program. You might be able to do that. So actually, keep an eye out on that. And then lastly, for Dan, when he talks about Camp Lejeune, he'll emphasize of just how fantastic and how important communication is and how that might be able to help you with doing some optimization on your physical sampling. So with that, enough from me. I'm going to go ahead and toss the baton over to David. David?
Thank you. So as we move into the topic and we talk about our PFAS RI UFP SAP process, we're starting out looking at the Naval Air Station, Patuxent River, and Webster outlying field. You can see Webster there in the north of the slide. It's on the Chesapeake Bay. And then south is Webster outlying field. It is on the shores of the St. Mary's River at the confluence of the Potomac River. To give you the history of the PFAS investigations to date, we completed the preliminary assessment in 2018. There were 16 areas of interest. We completed the site inspection in 2022. We did that as 4 sets of 4 AOIs. We awarded the RIs in 20 and 21. Then at Webster Field, we completed the PA in 2019. There were just 2 AOIs there. We completed the SI in 2021 and awarded the Remedial Investigation in 2021. So as I think about the PFAS RI UFP SAP process, the first thing I think is the approach is not fundamentally different from that of non-PFAS CERCLA RIs. We have limited sampling that indicates the presence of our compound. The SI data combined with conceptual site models suggests future RI sampling locations, but that suggestion is far from definitive. So what are you going to do? You're going to go out, you're going to install monitoring wells, you're going to collect and analyze media samples, you're going to review the data, and then you're almost certainly going to iterate. This is not to say that the initial effort should not be as comprehensive as possible, but it's extremely unlikely that a single field effort will fully define the nature and extent of contamination. So, you don't want to lose 4 months just haggling over which location might be best, because there are very few RIs that I know where one single field effort fully defined nature and extent of contamination. All right, so between Pax River and Webster Field, we had a combined 18 PFAS sites, all of which had funded RIs. So it was very important for us to focus the streamlining of the process. If you think about what it takes to get to a final UFP SAP, you're talking about scoping meetings with your regulatory partners. You're talking about scoping tech memos, the contractor's internal draft. You have the QDR process within the Navy at least. Then you have regulatory review, and each of these steps have response to comments, revisions, and sometimes multiple rounds. So the idea of going from award to final UFP SAP in a year or a year and a half is not unrealistic at all. So when we thought about our options for streamlining, we looked at combining sites. So 25% or more of any single PFAS SAP will be applicable to all PFAS SAPs at a given facility. Of course, that's at a given time. Regulations, RSLs, and the like are changing all the time. So when you move from one group to the next, you want to make sure you've got the most updated information. For Pax River, we did 4 sets of 4 sites, and for Webster Field, of course, we just combined 2 sites. We also removed any efforts that did not involve laboratory chemical analysis. This is the physical characterization. It's not required to be included in SAP. It can be presented in a simplified work plan, and it can be completed quickly. And most importantly, it can assist in your UFP SAP decision-making. So looking at Webster Field Site 34, it has relatively high concentrations of PFAS in groundwater. It is immediately adjacent to the St. Mary's River, so it's a very important site both for the Navy and the community. We wanted to mobilize as quickly as we could. We conducted the physical characterization in November of 2021, almost immediately after awarding the RI. We used the hydraulic profiling tool for conductivity. We looked at the groundwater surface water interaction. We did that via temperature, conductivity, pH, ORP, salinity, and also hydraulic pressure differential. We looked at the tidal influence, and we did the near shore sediment characterization by visually logging 2-foot sediment cores. This figure is a little busy, but it does give you an idea of the various places that we did our physical characterization. We took that information, the results of that physical characterization, put together a technical memorandum for the team and distributed. And then that way, when we came together for our scoping meetings, we had this information in front of us. And from that, this is what we came up for our initial go at remedial investigation sampling. Again, is this likely to produce 100% nature and extent of contamination? Probably not, but at the same time, it was certainly improved by having that physical characterization information. So if you're thinking about streamlining in the ways that we did, certainly you want to get team agreement early in the process. You want to know which sites you're grouping and why. In our case, we grouped by concentration. So the first SAP that we worked on were the 4 sites that had the highest concentration, although you might want to group on geography or some other criterion that makes sense for your base and your team. And then if you're going to do the physical characterization, you need to perform that characterization very early in the stages of SAP development. Those results will need to be captured in 2 of your SAP worksheets. And with that, I will be here for the Q&A, but in the meantime, let me turn it over to my colleague, Dennis.
Hey, thank you, David. I'm going to be talking about installation restoration site 6 at former Treasure Island Naval Station. And this site's a little bit different in that it's a single site as opposed to multiple sites where we're doing the RRI for, and it's a non-drinking water source area. So our primary risk concerns of this site were related to ecological impacts. So basically, IR Site SOAR was a former fire training school that was used from 1944 through 1992 for training activities. There was buildings on site, underground and above ground storage tanks, fire pits, central training yards, and a drainage ditch. They ignited fires on the site in buildings and pits and extinguished them. Various aqueous film-forming foam, the AFFF formulations were used. We don't have the specific information on which ones, but we know they were AFFF primarily. The drainage ditch was around the site that was used to channel wastewater to an oil water separator. And most of the features on the sites, the buildings and the tanks, were removed in 1993. And currently, most of the site is unpaved. This just kind of shows you where Treasure Island is. You can see it's sort of right there in the middle of San Francisco Bay. Okay, and this figure shows the site features, including the central training yard, which is surrounded by this sort of brown line, which was the drainage ditch. And this is sort of the primary source area, along with some of the former burn pits that were out there at the site. So this site has been investigated for a long time. The investigations began back in 1995, and we issued a non-PFAS record of decision back in 2014. Dioxins, furans, TPH, VOCs, PAHs were identified as contaminants of concern in soil. Excavations were used to remove these contaminants. There were excavations done for some of the CERCLA contaminants as well as some for TPH, and the excavations went as deep as 9 feet below ground surface at the site. No specific actions were performed in groundwater during the remedial actions at the site. Now groundwater is fairly shallow at this site. It's approximately 5 feet below ground surface. And as I said before, the groundwater is designated as a non-drinking water source. So, based on these ideas, we developed our conceptual site model. This is the conceptual site model for a risk assessment. So we're looking at human as well as ecological receptors in this conceptual site model to determine how we would perform our risk assessments for the site. For PFAS at the site, investigations began in 2015 with collection of some soil samples during some of the initial remedial actions that were done at the site for the non-PFAS compounds. And then in 2017, we started collecting groundwater samples as part of our base-wide monitoring program. And we found elevated concentrations of PFAS and PFOA in groundwater at the site. And we also collected some additional groundwater samples to help get a little bit more information on the extent of PFAS in groundwater. Now, we did a base-wide PA in 2020, which identified Site 6 as a potential PFAS-impacted site. However, because of the information that we had from our groundwater monitoring, we decided to move directly to an RI and streamline things and not go through the whole SI process, knowing that we already had quite a few PFAS at the site already. Okay, this figure shows what we had initially come up with for sort of the extent of PFAS prior to the performing the RI. Now it kind of goes out. It shows the concentrations for going out to the old sort of the concentration that was used, the 0.07 micrograms per liter for PFAS, which was used prior to what current regulations show. So the objectives for the RI, which are not really that much different from any other circling contaminant, were to assess the nature and extent of PFAS in soil and groundwater. One thing is, for our site, we need to determine if PFAS are migrating to San Francisco Bay, and determine whether PFAS in soil and groundwater present an unacceptable risk to site users and ecological receptors. So our planning process, we held preliminary meetings with regulatory agents to present our general plans for our RI at the site. And we got some comments. We received some comments from the agencies during these planning meetings. However, there were perhaps some things we didn't get into some of the subtleties of what we're doing at the site. So once we actually issued our written draft work plan, that's where we got our most significant comments. Some of the sort of the differences that we kind of gotten from this than we would get on a different type of circling contaminant is that the agencies were requesting, expanded PFAS analyte lists. There were some discrepancies regarding which screening values that we would use, and developing the consumption pathways for our conceptual site model, as well as determining how the previous actions that were performed on the site may have impacted the PFAS at the site. So our soil sampling was approached. We basically wanted to collect samples from across the site at some of the potential areas where we think that the PFAS would have been used, or the AFFF would have been used for the fire extinguishing. Samples were all analyzed for QSM using QSM version 5.3, table B-15. And one thing we did for our SAP was that we wanted to explain while we were collecting each sample at each location. So we presented tables with specific rationale for each soil sampling location. At each of our locations, we collected soil samples from 0 to 2 feet and from 0 to 6 feet. Now we use these data, the shallower data we use to evaluate risk to current recreational visitor or hypothetical resident, and the 0 to 6 foot samples were used to evaluate risk for future recreational hypothetical resident and a construction worker. So this map shows our planned sampling locations. So we kind of spread them across the site, all over the site, to try to get the nature and extent in the soil as best we could. Our groundwater sampling approach, we converted 15 of the soil borings that we performed to groundwater monitoring wells. And also at the site, for our previous work, we had 9 existing groundwater monitoring wells. And so we used a combination of the new wells as well as the existing wells to determine the lateral extent of PFAS in groundwater. So our groundwater PFAS data, what we did, we wanted to compare it. We put in our SAP that we were planning to compare to ecological screening criteria, which were available at the time. And as with the soil sampling locations, we provided the rationale for each groundwater sampling location in the SAP. And this map shows our groundwater sampling locations that we had. The ones in the larger type are the new ones that we installed at the site, and the wells with the smaller fonts in there are ones which were previously existing at the site. Another thing, because we were directly adjacent to San Francisco Bay, and one of our concerns was how the tidal fluctuations may impact the extent of PFAS at our site. So we did a tidal study, which to evaluate the communication between the site groundwater and San Francisco Bay. This allows us to further understand the ability of PFAS in groundwater to potentially discharge to San Francisco Bay. We were collecting data such as how far it is salt water intruding into the Treasure Island groundwater, how do the tides influence groundwater levels in the areas adjacent to the bay, could the salting out process, which is something that is of a potential concern, how does that impact PFAS discharge to San Francisco Bay? And do tidal forces, are they holding back the groundwater that may be impacted with PFAS? So using this, we basically what we found is that the extent of PFAS in groundwater was similar to what was previously determined during our groundwater monitoring. PFAS was detected at all of our groundwater locations, including those cross and upgradient from the source area. Now we've since did an SI across all of Treasure Island, and we are finding PFAS basically at all across Treasure Island, and a lot of them were at very low concentrations, but we weren't really seeing anywhere where that was completely absent of PFAS compounds. And we did have some PFAS that was detected in soil samples exceeding some of our screening levels we're using for soil. But what we found that was we had no unacceptable risk from exposure to PFAS only in soil and groundwater at IR Site 6. The tidal studies told us we have a tidal mixing zone, which extends approximately 70 feet inland from San Francisco Bay, and that as in this tidal mixing zone, salt water is intruding in, and that there are significant tidal forces which may impact potentially the concentration of PFAS that may be migrating to San Francisco Bay, as well as just adjacent to San Francisco Bay. This map shows the PFAS contours we came up with within groundwater using an ecological screening value of 0.117 micrograms per liter. So it's looks a little bit different than the previous map that we showed, but that's because we're using a different screening value for PFAS for this. So our path forward for this site, as David was saying earlier, sometimes that first go around is not always going to get you what you need. So we're going to continue onshore delineation of PFAS in soil and groundwater. We're also going to perform a cumulative risk assessment that includes risk from PFAS as well as the other contaminants that are remaining on site after excavations were performed. And we're also planning to perform some sampling in San Francisco Bay to develop ambient PFAS concentrations in sediment, pore water, and surface water. And once we can get resolution on those ambient concentrations, we're going to be collecting nearshore and or offshore samples in the bay of sediment, pore water, and surface water to see if we can evaluate whether or not the discharge is happening into San Francisco Bay. And that's it. And I will toss things over now to Dan Hockett to talk about Camp Lejeune. Thank you.
All right. Thank you, Dennis. So now we're going to talk about the processes that we went through to develop our UFP SAPs for our PFAS RIs at Marine Corps Base Camp Lejeune and Marine Corps Air Station New River. So this first slide shows a timeline kind of the PFAS evaluations that we did. Early on, the report went final in 2017. An initial on-base SI was conducted for some high priority sites where there were known AFFF releases. There were 7 AOIs, primarily firefighter training areas or emergency response sites. And then in 2019, we moved into we finalized base-wide preliminary assessment, which identified 52 additional AOIs. And then we began the SI, and based on some of the preliminary SI data, actually, we started an RI in 2021 at a high priority site, but then in 2022, we finalized that base-wide SI, and of all the AOIs that were evaluated, 52 were recommended for additional investigation, which turned out to be remedial investigations. And so take us up to today, there are 12 RIs in progress and 6 more in the planning phase. And in many cases, AOIs were combined into a single RI based on proximity, likelihood of commingling, the type and age of the release. And our team prioritized the RIs based on the potential for exposure, the proximity to the base boundary, proximity to major surface water features, and the relative concentrations that were detected during the SI. So the next slide just shows Marine Corps Base Camp Lejeune boundary. It's a very large installation. It's over 200 square miles. It's located on the coast, the Atlantic Ocean in southeastern North Carolina. So the next slide just kind of like shows a little bit of an outline of the next couple of slides. We're going to talk about the pre-SAP planning and the objectives development, how we developed our RI objectives. And then we got a slide about the approach to the RI to meet those objectives. A couple of slides on a case study at a very large site, and then a little bit of discussion about the challenges that we encountered that were unique to PFAS SAPs, and then some of the lessons we learned how to address those challenges. So the next slide talks a little bit about some of the pre-SAP planning work that we did. Like I said, this space is a very large active training installation. And we did SIs over more than 50 places. There were a lot of monitoring well infrastructure present, and there's a lot of just general aquifer well infrastructure at the base. And so one thing that was important to us is to go out and look at the sites where we were planning an RI and confirm that the infrastructure was still present and that could be used for the RIs. Which we did do. And then it was also important for us early on with our team to establish these consistent RI objectives, because we knew we were going to be preparing SAPs for a lot of different places over a relatively long period of time. We weren't able to do them all at once, and it was going to be a process. And so we wanted to come up with some solid objectives. And like everybody's been saying so far, not anything unique about these objectives. Evaluate site-specific geology and hydrogeology, delineate the nature and extent of PFAS with screening criteria in soil and groundwater and assess the risks, and also evaluate potential PFAS migration and exposure pathways. And this is what led us into the sediment and surface water media. We also wanted to have some flexibility in our SAPs to address some of the issues that David and Dennis were talking about. And so we developed with our team an agreed upon process for how step-out sampling could be dealt with if the initial samples did not achieve the objectives. And then we also had to agree on the sequencing of all the field activities with the team. And so one thing is, since there was already all this existing monitoring well infrastructure, our team decided together to collect the groundwater samples, like from the SI wells and any other existing monitoring wells that may be present in these investigation areas, from other types of investigations like old IR investigations or old POL investigations, to collect the samples from these initially from these existing wells to confirm the CSM that we went into in worksheet 10. And then if possible, if there were changes on these concentrations and some of the proposed samples needs to be adjusted, have information to check back in with the team to adjust these sample locations in order to maximize the hope of achieving the delineation objectives. And also we had to agree on the number of groundwater sampling rounds from all of these monitoring wells, and our team decided upon 2 rounds. So the next slide shows the approaches that we implemented and laid out in our SAP to meet the objectives that were laid out in the SAP. And so first of all, we too employed ECHPT work, mainly to evaluate potential confining units to help us plan out isolation casing needs for vertical extent monitoring wells that were proposed. The various fine-grained aquatards at this facility aren't at a constant elevation, and so we wanted to evaluate that through the ECHPT tool, and also to further refine our understanding of site-specific lithology and get hydraulic conductivity estimates with depth, which that tool provides. And of course, another approach to meeting these objectives is, of course, to collect the samples from the various media for PFAS analysis. At some of the sites where existing infrastructure facilitated doing so, we elected to conduct aquifer testing using existing wells where present, which was at 3 sites. And this allowed us to avoid a considerable amount of investigation-derived waste by using existing wells and not having to install new pumping wells. We also elected to collect some various types of fate and transport parameters to help us understand the mechanisms of transport of PFAS. And specifically, we wanted to look at things to evaluate leaching from the soil into the groundwater, such as these parameters listed out here: ion exchange capacity, TOC, and pH, but also how PFAS move once they're dissolved in the groundwater. And so we collected porosity and bulk density measurements through Shelby tubes, and also TOC and pH to evaluate PFAS movement within the aquifer. This is just a photo of ECHPT setup and an example ECHPT log. The next slide, we go into a case study that we wanted to talk to you all about. So this is a very large investigation area, which is an active flight operations area that includes a flight line. And it's a very large area. It's about 1,000 acres. There are 20 PFAS AOIs from the SI encompassed in this investigation area. And also there are historic IR sites within this area, mainly addressing VOCs, but there are also multiple UST and POL investigation areas in this large RI investigation area, some of which are under active remediation, and some of that is to address LMAPL that's present in some of these areas. And even though it's in the coastal plain in North Carolina, there are some complex groundwater flow patterns and surface water groundwater interface considerations at this site. You can see the picture on the right. You can see the New River Estuary is beyond the sonic drill rig there. And then on top of it all, there's an extensive amount of military construction underway in this area, redoing hard surfaces, building new buildings, replacing old buildings. So there's a lot of MILCON activity in this whole area. And on top of it all, from the SI, it was not clear in this large area if the PFAS impacts were commingled or not. However, what is known is that all of the PFAS releases are from a similar type of activity, which is some sort of AFFF usage or release. So because of all that, we elected to do this as one large area. And the next slide talks about how we dealt with what was a big challenge on this site. So because this site had such big history and it was so large, it was just not feasible to have one figure that shows all of this historic CSM type information, all the PFAS SI data, all the historical IR work that had been done, all the drainage features that were present there. And to try to have one figure, you just wouldn't be able to see any detail. And if you tile the figures into a bunch of static figures, you just lose context, about what's just off the page and everything. And so our team was really struggling with how to deal with this. So what we did was we utilized in real time a geographic information system during our scoping sessions and during some of the planning leading up to the scoping also. And it was an interactive GIS tool that had the ability to adjust the proposed locations as we were meeting with the team during scoping. And it allowed us to emphasize whatever the stakeholders' concern was. Some person might be interested in, well, what were the SI results again? Or how does this, where does this all drain to in this particular area? Where's the sub-drainage outfall? Where's these POL sites? Where's the LMAPL? whatever people's concern was, we'd be able to turn that on, zoom in and zoom out, and present all of the various media, proposed sample locations, groundwater, soil, surface water, and sediment. And it allowed us as a team, to dynamically in real time agree upon our proposed sample locations. That really cleared the way for us, and that was nice. So the next slide talks a little bit about some of the challenges we encountered as we developed these dozen UFP SAPs and getting ready to develop the half a dozen more. And one thing, Dennis and David made reference to this earlier, it's just a very dynamic regulatory environment. And, it seems like maybe things are moving along, but during the SAP process that we went through the last 18 months, there's just a lot of changes underway all the time. And there are changes to the various stakeholders' guidance documents that had to be taken into consideration, to address the concerns of the various stakeholders. And then on top of that, there's this evolving technology. For us, it was particularly around the analytical methods at the time while we were developing our SAPs, and, analytical method moving from various versions of various draft versions eventually to a final version. It brought up a lot of questions with our team and what it meant for the work that we were trying to plan out. And then there's also all the advances in the science and the understanding of PFAS, particularly as it relates to fate and transport mechanisms. So the next slide talks about some of the lessons that we learned through doing it. You see, it's kind of tongue-in-cheek, and the introductory speaker made comments about it, but it was so important for us to have a fantastic rapport established amongst all of our stakeholders, which we achieved through our partnering process. And so it was very important for us to communicate and track the decisions that the team made, because there was a lot going on while we were developing 12 SAPs. And so we wanted to make sure that we heard what various organizations' review comments were and employ those in subsequent documents. So we were very meticulous about hearing what reviewers say, whether it was internal or external reviewers, and making sure that that was incorporated into all subsequent documents so that we could avoid repetitive comments in future documents. And another big thing that we had to go through was to agree what was the critical path types of things we had to agree on. And for our team, it was delineating the nature and extent of the PFAS impacts, because the labs were going to be able to give us as good as they were going to be able to give us on detection limits. So agreeing on sample locations and media to delineate the nature and extent was a very important step that we had to take. But we also had to agree of how we were going to handle all this dynamic, regulatory changes that I talked about in the slide before, and how to incorporate potential changes to screening criteria as the investigation moved along through the field implementation and then transition into the reporting. So we had to agree as a team how we were going to agree to use whatever screening criteria were available at the time, and then how we were going to have a framework to revisit these for the data analysis once the data was received, particularly as it related to screening values. And then the other thing that we did, which allowed us to move into performing all these SAPs, was to maintain flexibility as we moved through the process. And what it did, all this communication and flexibility, what we found was by the time we were doing our last SAPs, they were taking 1 to 2 months less time than the first SAPs as we moved through the process, which was fantastic for us to be able to move in to the field implementation, which we are in the middle of the field implementation for many of these now. So those are just some of the things that we learned as we did our stuff at Camp Lejeune and Marine Corps Air Station New River. Thanks.
Okay, thank you guys. Thank you, Dave, Dennis, and Dan for your presentation today. So we've been collecting some questions, and I encourage the audience, feel free to submit additional questions through the Q&A box. So I'll start first with Dennis. Just a couple of questions here on Treasure Island. Is Treasure Island an NPL site or non-NPL site? I'll let you answer that before I ask the other question.
Yeah, it is a non-NPL site. So we don't really have the EPA. The EPA is not engaged at Treasure Island.
Okay, all right, thank you. And then related to your soil sampling, I think you mentioned a couple depths. If you could reiterate those for us, and then let us know, did you sample from like the 0 to 0.5 foot depth? Did you have smaller intervals within that depth?
Yeah, we had 0 to 2, and so what we did was we had our contractor use their geologists on site use their professional judgment to figure out where the best spot within that 0 to 2 foot interval was to collect the sample to send into the laboratory. So we didn't do anything just from 0 to 0.5 feet. However, we you know, several of the samples that were sent in were from that interval. However, we let them use their professional judgment in the field to collect those from the where they thought was the best location to get us the data that we needed.
All right, thank you. Okay, and I think the next question is for Dan. I know you just finished talking, but question here for you. I believe it's Camp Lejeune, where we went directly to an RI. Can you reiterate why this decision was made?
Actually, I believe that might have been Dennis's site that went straight to the RI. We went through the SI on all of our RI sites. So I think, Dennis, that might be you.
Yeah, I think I said, yeah, we at Treasure Island, we had started doing some monitoring at our existing monitoring wells out at the site back in 2017. And so we knew that we had PFAS and PFOA there above above screening values. And so that we knew that an RI was going to be needed there. So we didn't figure that an SI was necessary for the site, since we already had a significant amount of data showing the PFAS and PFOA there. So yeah, so we just kind of didn't want to go through that process because it just wasn't necessary. We knew that RI was going to be needed at the site. And,
Okay.
yeah.
All right, thank you. Okay, Dan, I'm coming back to you. Did you only use existing monitoring wells to delineate the site, or did you install additional wells?
No, there were additional monitoring wells installed, particularly for vertical extent evaluation. But where suitable, we took advantage of the existing infrastructure, you know, to be efficient with the investigation costs. But many new, much more new monitoring wells than existing ones.
Okay, all right, thank you. And this is for, I guess, all of our speakers, and Dave, you can answer first. Did you guys utilize any screening methods for rapid turnaround and to help make decisions before you use the DoD ELAP accredited method? Did you use screening methods prior?
We have not used screening methods so far.
Okay, what about Dennis? Dennis, did you guys use any?
We did not use any screening methods at ours. We were having, I know at the time we were having some issues with turnaround times, which were getting a little bit longer than we had hoped for due to the volume of samples that were going out from everywhere, I guess. But we did not do any rapid turnaround.
Okay, what about Dan? Did you guys use any screening methods?
No, we didn't either on these first 12, although we are strongly discussing it with our team as many new methods are starting to find more acceptance amongst the stakeholders.
All right, okay, thank you. So switching gears a little bit to talk about ambient or background sampling. You guys have any advice for the audience? Have you been involved in background sampling? And we can start with Dennis. Any thoughts there?
Yeah, we're right now in the process of trying to we've put out a draft work plan on how we're going to do that. And so we've gotten quite a bit of input from our stakeholders, the California Water Board and DTSC. So we're trying to work through those and come to an agreement on how we can do that. But you know, as we're seeing, you know, as we're doing this, we thought we were in a pretty good spot, and we had understood most of the concerns. However, we had some changes. One of the things you can't really anticipate, we had some changes in who were the our stakeholders, the project managers from the regulatory agencies that presented some different ideas for us. So we so yeah, so we're in the process. You know, we still haven't finished it yet, but we're working with everyone to try to get through that process. It's you know, becoming a little bit more complicated than we thought it was going to be originally, but we're trying to work through and get to there. But yeah.
Okay, Dave, any thoughts on this topic? Background, have
Yes,
you had
yes.
to do it?
Essentially the same as Dan. We have been working closely with Atlantic Division SMEs. We are in the process of drafting a background study. It has not gone in for QDR process just yet, the quality document review, but it should be going in soon. I think background studies are going to be very important. I will mention I did a non-CERCLA study in support of a MILCON at Naval Air Station, Tucson River, and we definitely saw concentrations that were indicative of what people call anthropogenic background. And I think background studies are going to be very important going forward with PFAS remedial investigations.
Right. Okay, thank you. And Dan, any thoughts on this background?
We are in the planning stages of preparing to conduct a background study. It's in the preliminary, very preliminary stages. And we think we're going to start with groundwater background first, and think about other media as we move forward.
Okay. All right. So coming back to you, Dan, question, you mentioned the challenges that you had to deal with, like changing regulations and guidance and analytical methods. So just curious, how did you deal with like every time a lower number came out, how did you deal with that throughout the process? Because you've been working on these sites for a while.
Yes, we updated screening criteria as they were presented to us, if it was within adherence to Navy policy. We had lots of discussions with the partnering team about this and about which compounds were applicable to the types of releases that we knew were present at our site. And then we just had to agree that we were going to move ahead with the agreed upon screening criteria. And if there were substantial changes that happened between the finalization of the SAP and when it came to time to do reporting, we would discuss those as a team. That's how we handled it. We everybody on the team wanted to move into the investigation phase, and we used the most up-to-date, approved by the DoD criteria, and moved forward from there.
Okay.
One thing I wanted to add one thing onto that, Ramona. For our SAP, we put in our SAP that we would adjust our screening values up to the point where we issued our draft report, RI report on that. So, you know, we knew that there was, you know, in a dynamic environment, and so we decided, you know, we'll move up, and then once we get to that stage, we'll stick with those once we issue our draft RI report. So that was how we handled that.
Okay. All right, thanks. And I want to circle to Dave. So we've been hearing that EPA doesn't want to accept things like agree to disagree memos and stuff. So did you have any specific situations where maybe you had to go head to head with EPA? Just curious if you had any situations like that and how you resolved it, or how did you work to get around anything like that?
At NAS Patuxent River and at Webster Field, we did not have any agree to disagree situations. So unfortunately, I can't provide any insight on that particular issue.
Okay. And so yesterday when we were preparing for this, you know, we talked about flexibility in in documents and in discussions. And I think it was Dennis and Dave, you guys mentioned that. Can you speak a little bit more about that flexibility to help prevent these types of situations from happening?
Well, this is Dennis. Yeah, one of the things I think that would help is having a flexibility in your contract that you have for going out and doing this work. I think as you're teaming up, by the time you get to any teaming up and discussing these things with your stakeholders, your contract would have been awarded. And so I know with our contract, we had a very specific saying how many soil borings, how many groundwater monitoring wells we'd install in there. So we had some very specific things in there, and we didn't have options in there for adjusting that. So when we had to make some changes to ours, we had to kind of go back through kind of a more full contract modification to do that. So I think one thing that helps you with your flexibility is having a contract which allows you some flexibility to adjust to stakeholder concerns about how you're going to perform your RI.
Right, thank you. So, okay, I have a question here for Dan on Camp Lejeune. So how did you determine that the existing wells at Camp Lejeune had not been impacted by installation or sampling activities or materials that may have cross-contaminated them with PFAS?
Yeah, that's a good question. And some of the wells were old, and so we did not know. So it was the data were taken and are going to be incorporated into the RI. We did avoid any monitoring wells that had permanent sampling equipment deployed in them, like pumps or passive soil samplers. I mean, not soil, passive sampling devices for other types of LTM that might be going on, to try to minimize the concern that was addressed, that was insinuated in the question. But otherwise we did not know.
Okay. And now, so a question for all of you guys. You've been at this for a while. What do you wish you knew when you started that would have helped the process? Any thoughts there? We can start with Dave, if you like.
Yeah, I'll start with me. Listening to Dan's presentation, one thing that I think is very good, and this comes back to flexibility, back years ago, we used to talk about dynamic work plans before we got into the sampling analysis plans, which are a little bit more prescribed than they were in the past. But that said, that does not preclude you from working in those preliminary agreements that say, if we see X in the field, then we're going to move out here, as opposed to necessarily coming back as a team. And as I call it, iterating. I think that is a very smart approach. I think it gives you maximum flexibility, especially if you've got the budget up front to go out and collect more samples. That'll really save time on the back end of, ultimately moving towards an FS and hopefully cleaning up your site. I think that's a great approach.
Okay, Dennis, any thoughts?
Yeah. I think one of the things that I was thinking, as I was saying before, having a contract flexibility to allow you to adjust things, sort of more so on the go than having to go back and do things through a full contracting process. And when you're having your upfront meetings, try to get into as much as you can into some of the subtleties of the work that may only be noticed generally when you actually issue a full-blown work plan on this. I know that was one of the things, and we didn't have some of the people who were commenting on our work plan weren't at our initial meetings, and trying to make sure that as much as you can, that everyone who's going to be commenting on your work plan and your SAP is there for some of these meetings. I know out here in California, we have a lot of, regulators where they have multiple people, sort of experts in the different portions of the environmental field who will comment on these. And a lot of times, a lot of these folks aren't necessarily at your initial planning meeting. So, trying to get people in your planning meeting as much as possible, I think, is something you want to try to work on, especially in this sort of dynamic field of PFAS.
Okay, thanks. And Dan, any thoughts there?
I would just like to second what David said about an iterative approach. The EPA triad methodology could become within our grasp for PFAS with these new screening methods that are starting to gain acceptance amongst the stakeholders. And I feel like it's just a very effective way to accomplish the objectives of an RI, particularly as it relates to nature and extent delineation.
Okay, thank you. So you guys mentioned flexibility in your contracts. So Dennis, how long typically is your contracting process?
Well, it varies. It definitely varies. Getting a full modification on that can sometimes take a couple of months. Whereas if you had options already on your contract, then that can take just a couple of weeks to get that process done. So that's why I was saying having some flexibility in there is helpful. It can take 2 to 3 months sometimes, depending on how busy things are. So yeah, and not to have everything so totally prescribed in your initial contract, it would be helpful as well, so you can adjust things. Yeah, we found that we had things very specific in our contract, how many wells, how many soil borings, which made things a little bit, when we had to change things, it made things a little bit onerous to do that, and delayed us getting out into the field.
Okay, so we heard from Brack maybe 2 to 3 months. How about ER? Dave, how long typically is your contracting process?
Yeah, I mean, it's generally considered a 3-month process, and we certainly strive to meet that goal. It really does not take too much longer than that.
Okay, thank you.
If it does stretch a little longer, it's not by much.
Okay. And one sec, I have one question here on screening methods. So which screening methods are you referring to that are gaining acceptance? Was that Dan who said that? So which screening methods are gaining acceptance?
Well, it is my understanding that various laboratory providers have various types of offerings of fast turnaround time screening methods, which are specific to either the technology or the service provider, i.e. the lab, and their screening methods. So they're not necessarily going to be ever EPA methods. They're screening methods to allow us to get fast turnarounds, efficient, cost-efficient results to help plan out sampling locations for permanent locations by EPA-approved methods.
Okay, and if I remember, I think we do have a OSD document that mentions screening methods, so maybe we can get that out to the audience. So we have a couple minutes left in our scheduled time. Did anyone from HQ want to say anything at all before we wrap up? Just want to give you the opportunity since a lot was said in this last hour.
I think you asked from HQ, which is me. No, I just want to say, hey, fantastic presentation to the three, to David and Dennis and to Dan. Again, I want to also welcome everyone and thank you for staying with us. It looks like we had 200 attendees at one time, which is fantastic. Again, just remember, we do this because of folks like you guys, everyone who is on and listening to this. If you have anything to share and you think that is great, that could help our restoration program, we would love to hear it. And maybe you'll be our next next one up to give someone else something to learn from your lessons learned. So again, I appreciate everyone's time and a fantastic presentation.
All right, thank you. Thank you, Melanie, and thank you again to our presenters. So we ask again that you please fill out the survey that you will receive after this OER2 webinar, and the recording will be on our YouTube page and on our ERB website as well. If you don't receive the T2 emails that tell you when these webinars are coming out, feel free to provide your email address and we'll ensure that you are on that list. So thank you again, everyone, for attending today.